Civil 3D offers powerful tools for railway design that streamline the creation and modification of rail alignments. To access railway tools, navigate to the Railway tab in Civil 3D's ribbon interface. This specialized tab contains all the functions needed for railway design. To create a new railway alignment, select Create Railway from the Railway tab. You'll need to define the starting point and the initial direction of your alignment. For railway projects, it's crucial to set the correct coordinate system and units. Engineers typically use UTM or other projected coordinate systems with units in meters or feet, depending on your region's standards. Railway design requires accurate terrain data. You can import survey data or existing terrain models into Civil 3D using formats like LandXML, DEM files, point clouds, or GIS data. Before designing your railway alignment, you need to establish design criteria. These include physical parameters like gauge width and clearance requirements, as well as technical standards that govern the design. To summarize, setting up a railway alignment in Civil 3D requires accessing the railway tools, defining your alignment's starting point and direction, setting the correct coordinate system, importing terrain data, and establishing design criteria based on applicable standards. The railway axis begins with creating horizontal elements. These include tangents, which are straight sections of track, circular curves, which allow the train to change direction, and spiral transitions, which provide a smooth entry from tangents to curves. To ensure safety and comfort, we must adjust curve parameters to meet design standards based on intended train speeds. The minimum curve radius increases quadratically with train speed. For high-speed railways, much larger curve radii are required. The vertical profile defines how the railway rises and falls along its route. Grade lines determine the slopes of the railway, which must be designed within acceptable limits for train operation. Vertical curves provide smooth transitions between different grades to maintain passenger comfort. Proper drainage is essential, with lowest points designed to allow water to flow away from the track. The Railway Section Editor allows you to apply standard cross-sections to your alignment. Here you can define all track bed layers, including ballast, sub-ballast, and the form layer. You can also specify parameters such as track gauge, cant, super elevation, and layer depths to meet design standards. After creating your railway design, it's essential to verify it meets all design standards. Civil 3D's analysis tools allow you to check for design violations such as insufficient curve radii or improper transition lengths. The system flags any values that don't meet the design criteria, allowing you to make necessary adjustments before finalizing your design. The final step is generating comprehensive documentation for construction. Plan and profile sheets show both the horizontal alignment and elevation changes along the route. Cross-section sheets display the track structure at critical points along the alignment. Quantity reports provide detailed material estimates for construction, including excavation volumes, embankment fill, ballast, and rail requirements. We've walked through the complete process of designing a railway axis and profile in Civil 3D, from creating the basic geometry to producing construction documentation.